As we look at this quiz, there was really good performance, especially for being the first electrochem. Question or part A may have thrown you off a little bit because it didn't have to do with voltage or current or cathodes or anodes, but it really comes back to what is reduction and what is reduction potential in terms of a reaction. So, as we think of things as most and least reactive, we're thinking about what can actually take an electron from something else. So when we look at these right here, PB can react with this, and in doing so, it will lose its electrons. So PB can react or can be oxidized by this process by losing its electrons to element X. Same thing down here. That makes PB the most reactive of the metals. Metals react when they lose their electrons. So PB is the most reactive. Q right here cannot lose its electrons or cannot react with element X. That means that it is very, very unreactive. So we're able to, by process of elimination, know that PB has to be the most reactive because it can react with both of the others. But since Q can't even react with X, it has to be the least reactive. This one's worth 2 points. If you got the order Q, X, PB, that was a 2 out of 2. If you got some of those right relative to one another, maybe X and Q in the right order, or PB relative to one of the others as the most reactive, that got you a 1 out of 2. On this next one, it was a lot more like what we spent a class time on. We got the drawings, we've got the solutions, we've got the ions, and we've got the metals. We would go through the paragraph there, and the things that I've highlighted is the most important part of that. So it doesn't matter what's on the left or on the right. What matters is the information that we have about what's happening with the electrons. It says that the electrons flow from PB to X. Electrons flow from anode to cathode. So that's our proof that PB has to be the anode. So once again, it doesn't matter what's left and what's right. PB is the anode or PB is losing its electrons. So right here, what you would have to do is write this reaction, but write it in the opposite direction. So whenever we see anode, we should think oxidation or losing of electrons. So whatever you wrote there, it definitely has to be something giving off its electrons. But from this paragraph up there, we can know that it has to be PB turning in the PB plus 2 ions and 2 electrons, or this equation in exactly the opposite direction. That was 1 point if you put that. Anything else, so this reaction not reversed doesn't get it, or anything with X does not get it. So really quick, I'm going to try to write this guy right there. If we know our standard reduction potential or our overall voltage is 0.47, we could think that has to be our cathode or our reduction minus our anode. One way we can do that, kind of ugly there, but we can read that is we know this. We know that this is the anode. So I wrote it here as the reduction of the cathode minus the reduction at the anode. You could also do X plus point or positive 0.13. Either one gets you that point right there. But the key idea of this is knowing what's cathode and anode and solving for that guy. The right answer in this case is 0.34. That was just 1 point. If you had a different answer on B, it's possible to get that full 1 point on C with a couple different answers, depending what you had. But the right answer to be consistent throughout is 0.34. When we are thinking about our electrodes right here, we can know that our cathode will get fatter. It gains mass, and the anode loses mass. So you could either describe those as the cathode or the anode, or you could say the lead loses mass and the unknown element X gains mass. Those were both acceptable. That first part right there got you 1 point. If you had something backwards before, you could still get that point if you're talking about the cathode and anode correctly. One thing that a lot of us did really, really well here was avoided the temptation to blame the electrons. Electrons are flowing, but those don't have enough mass to do anything. So the reason that if we come right up here, that our cathode gain mass is that these X plus ions, once they gain an electron, stick onto the metal. And if I was going to do my little pen right here, that X plus, instead of being floating around, is now stuck on as solid X atoms. What happens over here is that Pb, because it dissolves away, or because it loses its electrons, doing this backwards, it turns into that aqueous lead. So there's less of it as solid and more of it as ions. So you had to talk about the solid to ion, ion to solid situation for that second point. It's possible to get 1 out of 2 points either way, but it's really important to remember that the mass change is based upon solid to aqueous, aqueous to solid, not at all based upon those electrons. Right down here, the standard cell potential is used to do our delta G. It is negative N, F, and E. It's super ugly the way that I write it right there. But one thing that was important was you got a whole point if you just recognize that 2 electrons were being exchanged. So if you have an N equal to 2, you got a point. That is an important key here because at no point have we specifically answered that or pointed that out. So it kind of snuck in as a point right here, which is awesome. F is just something to plug in. The E was our answer from before. A few of us used the 0.34 or 0.6 or some other numbers that we had, but you should be using 0.47, the overall cell potential. Another important thing that a few of us missed was that negative sign. The delta G has to be negative to get the second point. So 1 point if you knew that N was 2, 2 points if you carried everything else through correctly. The answer should have been about negative 91 kilojoules or about negative 91,000 joules, depending which way you showed that. You could get the second point. Maybe you had a different value for N, but you plugged everything else in and you got that. And you got negative something else, negative 40 something, negative 40,000 something. That can get you a 1 out of 2, and that's good. On this one right here, the cation of K plus flows towards the cation. The cathode. The cathode is this solution right here if we have everything right up till now. So you could say towards the cathode, you could say towards the X plus, towards the XNO3, that would all be correct. And you could say because it's flowing towards the cathode, or really it's about replacing or being attracted to the electrons that it's gaining. That was 1 point. So if you recognized the right thing and made some reference of charge or cathode or something along that, you got those points. Right here, we bump that and we move the salt bridge out. It takes our voltage to 0. If we don't have a salt bridge, we don't have a circuit. So if we disconnect a wire, we don't have voltage. If we disconnect our salt bridge, we don't have voltage because charge can no longer flow. That was 1 point. It didn't have to be super, super specific, but it had to be no voltage because we were no longer connected. And right here, the last point, and sometimes the wording makes this a little bit confusing. And we haven't talked in detail about non-standard cells, but this is a place where we can kind of use common sense. So they leave the switch closed. That means that it's turned on. So when we scroll back up here, the switch is open, which means it's not connected. When we close that switch is when we turn it on. The next day, the student reads the voltmeter before turning it off. Well, if it's been running all night, we're using up chemicals and the voltage is going to be less than 0.47. So a battery will start to die, and especially an electrochemical cell. Batteries that we use are made to be run for a very, very, very long time with super high concentrations and multiple cells in there. But when you set up a series of solutions with just 1 molar and you run that all night, it's going to start to die. And if you're really savvy at math, we know that's 1.1 plus 1 plus 1. We're up to 3, 4, 5, 6, 7, 8, 9, 10, 11. There was 11 possible points here. I'm still entering it or entered it out of 10. So if you did get an 11, but because this was a little bit tricky and we hadn't talked about it, or maybe there was something in here you weren't expecting this, you could still get a really high score without totally knowing each one of those. But even totally ignoring the fact that there was that extra maybe bonus point hidden in there, our scores were awesome. Anytime we do a first quiz, it's hard. And anytime we're doing something where it's asking the same skills, but in a totally different way. This was the same stuff we talked about, but presented very, very, very differently. And you did really well, where we were problem solving our way through it. So we'll see more electrochemical cells, but really the key is looking at the picture and reading the words to get some information about where the electrons are going to or coming from, or what our cathode is or what our anode is, based upon our definitions of anox, red cat, Leo, Gur, and the idea of that fat cat.